So a reaction has the stoichiometric equation A plus B forming 2R. What is the order of the reaction? So a very simple statement and a very simple question, but this boils down to your basic understanding of the concept of finding the order of the reaction and the rate constant. So if I may ask, so you are asked to determine the order of the reaction based on the stoichiometry. Now, can somebody answer this one? The reaction has a stoichiometric equation A plus B forming 2R, and you are asked to determine the order of the reaction. What do you think would be your answer here? Or how would you answer this one? What do you think, Giselle? How do we answer this particular question? What is the order of the reaction?
Wait lang, good miss. Order of two, miss.
Oh, what's your basis in answering 2 for the order?
Ano ko siya, miss, if based sa stoichiometric equation, pwede ka ka-form rate expression. And the rate expression would be rate of A is equals to K CACB.
That is correct on the premise that, so that would be correct to sell
Miss.
actually.
If elementary ang reaction.
Okay, so actually, okay, very good. Actually, if you have read through concepts of order of the reaction, the order of the reaction is never based on the stoichiometric equation. So Levenspiel purposely placed this particular question here, though very simple, to check your understanding of how we determine the order of the reaction, because that's the question in here. The way we determine the order of the reaction is based on a set of empirical data. It's not based on the stoichiometric equation that the problem proceeds. So the answer of Giselle would have been correct if, before answering, she would have said that if the reaction is elementary, then the reaction order is 2, based on the stoichiometry that is provided, or based specifically on the coefficients of A and B as they are written in the stoichiometric equation. But if this particular assumption is not valid, that the provided chemical reaction is elementary, the answer here should have been it cannot be answered, because you can only answer the order of the reaction, then the rate constant, if you are provided with a set of data that will allow you to solve for it. The one that we have discussed last meeting is how we should interpret the set data. That way, we can determine the order of the reaction. So Giselle, take note of that. So if you would be asked this particular question, actually the answer it cannot be answered unless the problem tells us of assumptions that are properly placed in the problem or nahambal siya sa problem nga amo na. Okay? Now, we go
Okay,
to two.
miss. Yes,
Okay,
miss.
okay. 2.2. Given the reaction 2 moles of nitrogen dioxide reacting with a half mole of oxygen, forming 1 mole of dinitrogen pentaoxide, what is the relationship between the rates of formation and disappearance of the 3 reaction components? So this is very elementary. But I'd like to ask, let's see, who would like to answer this so that I will not have to call a name. How would you express the relationship between the rates of formation and disappearance of the 3 reacting components? Let me see. Would that be Jules Santiago? Can you please tell the class of how are we supposed to write down the relationship between the rates of formation and disappearance of the 3 reaction components? So you're given, I'll write here the reaction. That way, you won't have to go back to the problem. So it's giving you NO2 plus 1 half O2 forming, okay, let me check. So you have 2 moles and 1 mole, okay, of dinitrogen pentoxide. So we have 2 moles of this and forming 1 mole of dinitrogen pentoxide. So this is our stoichiometric equation, joules. And the problem is not asking you to determine any specific quantity, but rather you set up an equation that will um, illustrate the relationship between the rates of formation and disappearance of the 3 species that you see. Now, the 3 species that you see are NO2, O2, and N2O5. How would we go about doing it? Or let's say, to simplify things, I'd like N, this is 2A plus 1 half B forming D. Now, how am I going to write the rate expression or relationship for the rates of these species that appear in your stoichiometric equation?
Uh,
I can dictate to me, I can write it. So how would you write the relationship? We're done with this.
mm,
The rates, so in terms of relationship, Joss is asking for you to write the relationship between the rates. So I will place here I, and you have here the reason why I write negative to this two is because they are species and this one is a product. So complete what I have written here. That way, we will have a relationship between the rates of disappearance and formation of the species.
miss, negative RA over 2 is equal to negative RB over 1 half is equal to negative RD over 1.
Okay. So, amo ni siya ang ginapangayo sa problem. You set up a relationship based on the stoichiometric equation on the rates of disappearance and formation of the species as they are provided in the problem. So, this is your answer already in itself. The rates of uh, disappearance of A and B related to the rate of formation of D. Okay? Now, we proceed with the next. So we go back to Levenspiel and check what we have there. Okay, so 2.3 says that a reaction with stoichiometric equation 1 half A plus B forming R plus 1 half S has this particular rate expression or rate law. So the rate of disappearance of A is equal to 2 Ca raised to 0.5 Cb. Now, what is the rate expression for this reaction if the stoichiometric equation is written as A plus 2B forming 2R plus S? What do you think would be the rate expression or simply rate law? If the rate law for this one is this, what do you think would be the rate law for this one? Yes,
The same lang,
Marcel.
miss.
Marcel,
The rate expression would be the same na, miss. Since
why?
nga wala relation ang stoichiometric, um, ano nila, ang stoichiometric sa rate expression.
Okay. What do you think, Joanna? Do you agree with Marcel that uh, actually what happened here in A plus 2B forming 2R plus S is that you have multiplied the stoichiometric equation by 2. So you get rid of the 1 half and you introduce 2 as a coefficient for B and R. So do you agree, Joanna, with Marcel
Yes,
that
miss.
the rate law is still the same?
Yes, miss. Kay hindi dependent ang aton nga rate expression sa previous nga stoichiometric equation whether ginlain siya miss.
Okay, so
Based man sa previous nga list.
okay, sige. What do you think, Antoinette? Do you agree with Marcel and Joanna that your rate law is still the same?
Yes, yes, I do agree, yes, that they are the same.
Again, Antoinette.
I do agree that they are the same expressions.
So same. Is it the same? Antoinette?
They are missing.
Okay. So the three are correct. So very good. So Marcel, Joanna, and Antoinette is correct in saying that your rate law will be the same because we're talking of the same reaction, only that the stoichiometric equation was changed. If it's the same reaction, your rate law should be the same because your rate law is based upon data that was gathered through a series of experiments that will establish the N and the K. Okay, we proceed with 2.4. So for the enzyme substrate reaction of example 2, it's an example that is discussed before this set of problems. The rate of disappearance of substrate A is given as this. So this is the rate in which A disappears in your given enzyme substrate reaction. What do you think are the units of the two constants? So I'd like to you ask somebody here or anyone who could answer. You can raise your hand. What do you think are the constants that this particular problem are referring to? So it says here, what are the units of the two constants? So if it's asking for the units of the two constants, what are these constants in the first place? What do you think are the units of this constant? Or rather, what are these constants first before we establish their units? Hmm? Okay, let's hear from Socrates. What are these constants, Socrates?
Um, the 1760 is the uh, the 6 is mole per cubic meter. Then the 1760 is the uh, second per second lang na miss ang units ya.
Okay, sige. So you're telling me, nag-answer ka na actually, Sok, no? You're telling me that the constants that the problem is asking for the units would be the 1760 and the 6. Okay, so you said you're correct. These are the constants that the problem is talking about. Now, you said that the unit for the 6 is mole per cubic meter and the unit for 1760 is per second, right?
Yes, miss.
Okay, sige. So take note of that, class. The unit for the 6 is mole per cubic meter and the unit for the 1760 is per second. Okay, I wonder where's the rest of my students. Do you agree, Renzo, the units that Socrates provided for us, the 6 and the 1760?
Yes, miss.
Okay, so you agree that it's mole per cubic meter for the 6 and 1760 is per second. So Renzo agrees with Socrates. So we'll have another one. Maybe Raymond, do you agree, Raymond, that your unit for 1760 is per second? The unit for 6 is mole per cubic meter.
Yes, miss. I agree, miss.
Okay, sige. To check whether your answers are correct, so let's go back to the board. So your rate expression is 1760. Then you have, this one is concentration, and this one is, what's E? Anybody? What's E? Wait, let me check again. Is that CA? Okay. Now, you do not know E sub O. So we will go back to example 2 so that you will know what this E sub O is. That way we will know its unit. So example number 2, because it's referring to example number 2. Okay, we're here. The enzyme substrate reaction and the rate law and E sub O, a rate proportional to the concentration of the enzyme is introduced into the mixture. This one is the concentration of the enzyme. Do you see the PDF copy that I am sharing with you?
Yes,
Yes,
Miss.
Miss.
Okay. So E sub O as defined is the concentration of the enzyme. Anyway, you know that whenever we have these brackets, they mean concentration. So concentration of the enzyme. Now, the A is the concentration of reactant A. So the one that has the bracket. Now, so that's it. We have defined already the two. So we go back to the board and see whether the answer that was provided is correct or the answers are correct. So if this particular rate expression, or yeah, it's a rate expression or rate law, will be having this set of units, the denominator in the first place should be dimensionally the same. So they should be the same. So if this concentration of A should be mole per cubic meter, it follows that this 6 that we're talking about asking for the concentration of should be in mole per cubic meter. So this one is correct. Now, the denominator then has the unit mole per cubic meter. Now, in the numerator, I have 1,760 and I have here mole per cubic meter. I have here mole per cubic meter. If I will cancel this one with the set of units that I have in the denominator, I have already remaining here mole per cubic meter. So then it follows that the 1,760 should have a unit of per second. So that's how you go about determining the units of the parameters or variables that appear in your rate expression. So the answer of the three guys, Socrates, Renzo, and was it a guy that I asked? But the three are correct. So you have mole per cubic meter for the 6 and per second for the 1,760. So we go back to Levenspiel and check for more problems that we can answer. We're here. So we're done with that. We're here 2.5. For the complex reaction with stoichiometry A plus 3B forming 2R plus S, and with the second order rate expression as given, are the reaction rates related as follow? So we say that the rate in terms of A is equal to the rate in terms of B equal to the rate in terms of R. If the rates are not so related in this manner, how are they supposed to be related? Properly affix the sign. So please account for the signs positive and negative properly. So do you think that if this is the way we write the rate in terms of A, the rate in terms of B, and the rate in terms of R should be all represented in the same manner that we have represented A? Or is it R sub B is also equal to K times A times B, concentrations of A and B. And same thing with the rate in terms of R. Would it be the same in the same manner represented as exactly the same as of A, or the rate in terms of A? Anyone who can answer that? Hmm? Do we represent all rates in the same manner? Too easy? Oh, sige. If it's too easy, then we will have the next. Do you know how to answer this? It's too easy, miss. Can we have something complicated? Let's see. Marcel, how do we correct this, Marcel? Or is there's no need to correct?
Um, I think miss, um, matter gid ang sign and also ang stoichiometric component ay nga numbers ang kada reactant or product sa rate expression ay sa rate
What
ng
did you
formation.
Okay. What did you mean ma-matter ang, so you said the stoichiometric equation will matter, and you mentioned something before, pardon, I was not able to hear it properly.
Okay.
Ma-matter ang
Ilang nga stoichiometric nga nga
before that you mentioned something. What was that you mentioned? Ma-matter
ang sign.
Ang sign. Okay. It's the sign and the stoichiometric equation. So okay. So if this is your stoichiometric equation, how would we properly represent it, Marcel?
Reaction
Relationship.
rates.
How do I
Yes.
write it?
So it should be ang like sa diin nga part nila ang stoichiometric nga
It says here that RA is equal to RB equal
yes.
to R sub R. You don't agree with this, right? So how should we write this?
So negative RA all over 1 is equal to negative RB all over 3 is equals to positive RR all over 2.
Thank you, Marcel. So this is correct. So this particular relationship here provided is wrong. It's because the relationship between the rates is not dependent on the rate law. The reason why it's written here, though very simple as it is, it's not dependent on the rate law, but rather the relationship with the rates is dependent on the stoichiometric equation provided. Okay, now we proceed to 2.6. So you're given a certain reaction which has a rate of 0.005 Ca squared, having this set of units. If the concentration is to be expressed in mole per liter and the time in hours, what would be the value of the units, the value and units of the rate constant? Okay, so I need help here. Who can help me here? What would be the value and the units of the rate constant? If you're the one solving this, what would be the first thing in the first place that you will do? What is the first thing that you will do if you're the one solving this problem? Sarah, how would you start solving this problem?
Good afternoon, Miss.
Afternoon.
Hindi lang ko sure, Miss. Pero
Sige.
for me, I will start by equating guro siya, Miss, to the rate constant. Nga K is equals to negative RA over the concentration of A squared para ma-figure out ko ang units nga appropriate sa K, Miss.
Okay. Now, I'll simplify things, Sarah. Okay. This is your rate law. Okay. This is your rate law. And this rate law is provided with a set of units telling you what should be the set of units for the concentration and what would be the set of unit for the time. So concentration must be in terms of mole per cubic centimeter and time should be in terms of minutes. Now, the problem is asking for the value and units of the rate constant. So, the value and the units of the rate constant. Now, it would help if you start with determining what is this rate constant. In the original expression that is provided, what is the rate constant, Sarah?
Ang 0.005, Miss.
Correct. So I will write it here. Correct. Your rate constant, change this. Your rate constant is equal to 0.005. If I will ask you, what do you think is the set of units of this original rate constant, which is 0.005? What is its set units?
For the 0.005 na gid, Miss.
Mm-mm.
Siguro, Miss, mole per centimeter cube times the time nga minute over sa mole per centimeter cube squared. Bali, Miss, try ko, Miss, Miss, gin-equate ko, Miss, siya sa K.
Okay. So,
Mana, Miss,
ano, so,
tapos ma-negative RA over sa concentration sang A nga squared. Tapos, i-follow ko lang, Miss, ang ilang nga units until nga ma-cancel ko, Miss, ang centimeter cube kag mole nga naka-squared.
Si ang imo nga minute nga time diri gini siya mahalin, di ba, Sarah? It should come from here.
Miss.
This minute should be introduced in the rate constant. Now, you should have a mole per cubic centimeter. Now, this mole per cubic centimeter came from the units of the concentration. However, look at the units of the concentration. It's squared. So you have to get rid of one set of unit of mole per cubic centimeter. And you have to introduce that in here. That way, you will have a set of units for the rate law, which is like this. So what do you think will be the placement of the mole and the cubic centimeter in your rate constant? That way, when you combine now these two, you multiply the 0.005 with its units and the CA squared, the final set of units would be this. What do you think, or how do you place in the mole and the cubic centimeter in the K?
Meter cube per mole minute.
Correct. So meter cube. So it's cubic centimeter iha. So cubic centimeter per mole.
Sorry. Mole, Miss.
If you multiply cubic centimeter per mole to mole per cubic centimeter quantity squared, you will have this as the result. The unit for time, which is in minutes, is already in here. Okay? So this is your original K. Okay? Now, the problem is asking the value and the units of the rate constant if now this time you will change the units to mole per liter and for the concentration, and time should be in hours. That would be a simple case of
dimensional analysis, Miss.
or conversion of
liter to centimeter cube, Miss.
Okay, so in this case, we'll go here. That way it's clearer. So if your K is equal to 0.005 cubic centimeter per minute per mole, this would be converted to, so as you said, it should be converted to, so the cubic centimeter is 1,000 cubic centimeter in 1 liter. The mole, there's no need to convert. You convert the minute to hours. So what would you do here? Multiply by 60 and you have 1 hour here. Okay, 1 hour. So that would now be, this would be now the new value of the rate constant with the new set of units. Okay? Do you get it?
Yes, miss.
Okay. Anybody who has a question? So you just have to do the maths in here. You multiply by 60 and you divide by 1000. That would be giving you a set of units, which is liter per hour per cubic meter. Oh, per liter per mole. Sorry. That should be liter per mole. So that would be liter per mole per hour. Okay, so you have your value here after you do the mathematics. So we go back to Levenspiel. Now, for the gas phase reaction at 400 Kelvin, the rate is reported as. Notice that this time the rate is expressed in terms of partial pressure and time, because we are allowed to do that if our reaction is gaseous, or our reaction mixture is gas. What are the units of the rate constant in here? So take note that your rate is atmosphere per hour. So what do you think would be the units of your rate constant? We can have Emilio. What is the unit of your rate constant? Or in the first place, what is your rate constant? Emilio?
Miss, good afternoon.
Afternoon.
It's 3.66 over ATM R.
Wait. Your 3.66, sorry. This 3.66, I'll write here, should have a unit of
3.66 over ATM R.
correct. So it's over ATMR. You have to cancel one of the ATM unit here and introduce the R unit. So this is your units for the rate constant. Now, what is the value of the rate constant for this reaction if the rate expression is expressed in terms of this? So meaning, instead of having a unit of ATM per hour, now you should have a unit of mole per cubic meter per second. And your rate law will now be in terms of concentration, not in terms of partial pressure. Okay, this is similar to the quiz that I gave you, right? So if you practice solving here, you can get that particular, you can answer that particular part in the quiz. So I will write the original in the whiteboard so that we will know what to do. Okay, new. So your original rate is equal to 3.66 per ATM per hour. And this is partial pressure raised to 2. It's converted to rate in terms of kCa, where this one will have a unit of mole per, I forgot, this is second. Is this cubic meter? Let me check. Oh, it should now be mole per cubic meter per second. Okay, that's it. So the big question, according to Levenspiel is asking what is now the value of the new K if from this original rate law, wherein rate is expressed in terms of partial pressure, you have converted it to kCa. Okay, let me check if I have copied the 3.66. Okay, it's 3.66. Now, anybody who can tell the class of what's the right, what's to be done in here? So from the 3.66, you will have to convert to a K. which should be in terms of mole per cubic meter per second? Anybody? Anyone?
I-use ang ideal gas law.
We use ang ideal gas law. How do we use the ideal gas law?
V is equal to N over V, which is the concentration, times RT.
Okay, I will write here PV is equal to nRT, right? So you're telling us P over RT is equal to N over V, which is said is the concentration.
Yes, miss.
Mole per unit volume. How do we use this one in here specifically? So you have this one, we call this the 3.66 per ATM hour. We call this specifically in some books, it's labeled as K sub P. It's the rate constant based on partial pressure. This one specifically, although we don't write it anymore, is K sub C. It's based on concentration. So actually, the question now is, how would you convert from K sub P to K sub C? Anyone? I'm sure somebody may have an idea. How will you convert from the K sub P that you have originally, which is 3.66, to K sub C in here? So it will have a new, of course, it will have a new numerical value and it will have a new set of units because this time you're dealing with concentration. Anybody? This should be squared. So how do we convert? Anyone? Anyone who knows what to be done? That's correct. You will use this conversion. The question is, how will you use this conversion?
Hello, miss.
Yes. Yes.
Nang
Yes, Eugene.
i-rewrite ang R sub A as a differential, miss.
Okay. Okay. I will go to a new slide. Dictate to me, what do you mean? You have rate. This is what you mean, Eugene. dCA dt?
Ng dPA dt, miss. Sa original, miss.
Ang sa original. So, this should be, okay, dali lang. So, this is dCA dt and this is K C sub A squared. This is the new one. In the original, we'll go to the original. So, Eugene wants us to start with the original. So, you have rate. This is negative dPA dt. Is this what you mean?
Oo, miss.
3.66 PA squared. Oh, go. Dictate to me what you want here written.
Tapos, miss, asa P sub A bilang miss sa differential, ag sa rin miss sa 3.66 nang i-convert to sa miss sa ano to ganin.
Sa concentration.
Oo, miss.
Okay, so you mean, if I recall, the equation that we have, P sub A over RT, I'm now labeling it as A. This is equal to concentration. Is this what you mean? And then
Miss, bale
C sub
ng
A is C
CART,
sub
miss.
A RT.
Miss.
Oh, so I write it here. So D, I'm now your secretary. C sub A RT dt. And I have here 3.66. Never mind the units of that. Then what do I do, Eugene?
CART squared din. Nang substitute lang niya po.
CART quantity squared. Then, proceed. What's the next step?
Kaya ang RT, mas pwede sa, di ba, mapagwa, may sa Ay,
Correct.
constant na rin na
Why
difference.
can you? Correct. You can place this before the differential, negative RT, then this must be dCA dt is equal to negative, no, sorry, 3.66. Same thing here,
CA
CART,
squared.
CA squared. Sige, you want it isolated and we have
Hanggang
this
RT.
squared. Wait, Antoinette.
Ah,
Okay, then what do? We,
cancel, miss.
okay, we cancel. Oh, so we cancel this one, we cancel 1 here, right? So you have
Miss.
negative equal to negative dCA dt is equal to 3.66. Excuse me, class, ha? Somebody is calling. Wait lang. I will just have this pause. Okay, class, sorry for that. Anyway, did I pause the recording? Am I sharing now? Hello, class?
Yes,
Yes,
miss.
Yes,
miss.
Okay,
miss.
okay, okay. So, okay, that was emergency. Anyway, you have negative dCA dt is equal to 3.66. And Eugene say this is, I should place here RT, Eugene. You still have one set of RT. And you have here
Miss.
CA squared. Okay?
Yes,
Then,
miss.
Eugene, what is it? Actually, it's apparent already what is it. So, this is your R sub A. So, this is now your, what is this now, Eugene?
Ng new rate constant,
So,
miss.
this is your K sub C, right?
Miss.
Oh, very good, Eugene. Very good. So, you have K sub C. I'm writing here. Therefore, K sub C is equal to 3.66. This is, remember, as Emilio is saying, ATM per hour, right? We multiply this with the R. What R will you use since our unit is ATM per hour? What universal gas
Uh,
constant is appropriate if it's
Zero
ATM?
point zero eight two
Oh,
zero six.
correct. So it's 0.08206, right?
Yes, miss.
ATM liter
Later.
per mole Kelvin. Then the temperature, are we provided with the temperature?
Yes, miss.
What's
400 Kelvin.
400 Kelvin? So this is 400 Kelvin. So you have this and you cancel this. So your new set of units, I'll leave the value to you, will be liter per mole per hour. So very good, Eugene. And for the rest who were able to answer this last time. Okay, So the treatment of the problem I gave you is very similar to this problem that was found in Lebenspiel. Okay, or that you can find in Lebenspiel. Before we move on, do you have any question?
Hello, Miss.
Yes.
Mamangkot ko tanong, Miss, if ano ang
Oh.
relations ang order of reaction sa rate expression mo? Ay sa mga, especially sa mga units, bala Miss.
Dali lang. I-rephrase ang question. What is the relation of
Sang total order of reaction
total order of the
sa
reaction to
the units, bala Miss? Or sa K mismo?
Specific na lang. So you are asking me what's the relation of the order of the reaction to the units of the K in terms of converting from K sub C to K
Yes,
sub P or vice versa. Okay.
Mhm.
Maybe a classmate of yours knows how to answer it based on the exercise that we did. I am waiting. What do you think is the answer to Marcel's question? How do we convert from KP to KC or vice versa? You could see it here in the you could see it here in the exercise that we did. So we have K sub P, right? Then what did we do to the K sub P?
Multiply sa
Use the
RT.
ideal test.
Multiply so it should be the entire thing, right? RT, right? Right?
Yes, Miss.
I'm letting you answer your own question, that way you get to think. Then what will I do with this RT?
Substitute ang mga constant values here or ang given values.
Dali
Para
lang.
maanong unit.
Marcel, you're asking me for a formula that will relate the order of the reaction in the process of converting from one rate constant to another. Is that okay? So
yes,
what
tama na.
now I'm asking your classmate to think and tell me the formula that will answer your question. So I'm letting your classmate answer your question for you. That way everybody gets to think. So I'm guiding you. So this is KC, that's your KP. What you did is simply multiply by RT, right? R and T. So I place it there as as one whole thing, one entity. Then the next question na lang, Mangid, is where will I place the N? Because that was your question. What's the relationship, or how do I place in N in the conversion from one rate constant to another? I'm sure somebody knows. So what will I write here? Hello? Anyone? No, you multiplied by RT. So Marshall is saying, give me a formula, miss, that I can work anytime that I want. As long as I know the N, I can easily convert from one rate constant expression to another, meaning from KC to KP or vice versa. What would that be? Alright na siya. Anyone? It's what? You can guess. There's nothing wrong with guessing. It's what?
Molar volume, miss.
Molar volume? No, not molar volume. What we need to incorporate in the formula here is what Marcel is asking from me, actually. He wants in the formula the N. Yes. Go. How will
sa numerator, miss?
Sa numerator.
Sorry. Ang
Go.
power sa exponent nga part.
Sige. You answer your question. Ano obrahon ko, Marcel?
Di. Banta lang isa, miss. Bali, KC is equals to KP. RT raised to N.
N minus 1. What's the order of the reaction? 2, right?
2, yes.
Oh, subtract 1, meaning it's 1. That's the one that we did here. So if the order of the reaction is 3, this would be 3 minus 1. So this should be squared. The product of these two should be squared. Okay? You get it?
Yes, Miss. Noted.
You have Marcel to thank for asking a very good question. So you have now a formula that will convert from Kc to Kp or Kp to Kc. So if it's Kp to Kc, that would be Kc or K sub c multiplied to RT raised to 1 minus N. Okay?
Thank you, Miss.
Okay. Okay, sige. So we proceed to, okay, we'll use the next link. I will stop in here. I will stop recording here. We'll use the next link. We reconnect, okay? I'll see you in 2 minutes.